Hey guys, welcome back to Learn Python the Hard Way. In this exercise, we're gonna dive deeper into object-oriented programming and learn about modules, classes, and objects. And as always, you can find the link to the current chapter, to the current exercise in the description below. This is part of the paid section of the book, so you would need to purchase the book to follow along, or alternatively, of course, feel free to just follow along with the video. So in the previous exercise, we already got started with some aspects of object-oriented programming, and this time we're going to dive in a little bit deeper. So Python itself is an object-oriented programming language, and that means that Python uses classes to basically structure the software that we're writing in a particular way. So that allows us to add consistency to our programs and use the code in a cleaner way. So let's get started to understand object-oriented programming, or OOP, a little bit better. And to get started, first of all, let's create some comparisons to what we already know about. So modules, which we are going to use when we work with object-oriented programming, are like dictionaries. We already know how to create dictionaries and how we can use them, and that we can use them to basically map one thing to another. So for example, we could create a dictionary mystuff and have a key in it, for example apple, and then a value, for example the string I am apples. And then we are able to print out the value of our dictionary here, which is corresponding to the key that we pass in. So if we want to reproduce that, we can open our terminal and switch open our Python interpreter by just typing in Python followed by the name of the Python version we are working with. And then we can create a new variable. We can use the curly braces to create a dictionary, and we pass in a key followed by a colon. And then of course after that we pass in the value. Once created, we can simply print out the value of our dictionary by passing in the value of our key, so in this case apple, and we get back the value that we defined. So this idea of basically getting x from y using the key and the value in the case of the dictionary, that's something we should keep in the back of our minds when we're actually working with modules. So we already know that the Python file has some functions or variables in it, that we can import a file and how we can do that, and how we can access functions or variable in a module using the dot operator. So just in the same way as how we used basically or defined functions before, we can basically create a module and import that to work with a function. So to do that, let's create a new Python file called mystuff.py, and let's define a function in there. And to do that, we can go back to our terminal here, and then I'm using Visual Studio Code, so I'm just going to type in code space and then the name of the Python file that we want to create. This is going to open a new text file, a new Python file, and then we can just basically define our function in there. So we start out by defining the function apple, and all the function is going to do for now is to basically print out I am apples, basically the same what we added before to the dictionary. Let's save this, and now let's go back to our terminal here, and again we're going to switch over to the Python interpreter. And now we are able to actually import whatever we wrote in our function by just typing in the name of the Python file without the py at the end, to basically import our text or our code that we just wrote. So let's do that. And after that, we can actually type in mystuff, which is basically the name or the module we imported, followed by the call to apple, which is of course a function we defined before. And now we execute that function here and we print out IMApples. So that's basically how we would use it. What we can also do is we can of course include additional information in our function here, or rather in our Python file, our module that we are writing. So in this case here, we could, for example, say outside of our function, but still inside of the file, we define a variable. Let's call it tangerine, and associate it with a string like this. Now we can save this and now head back to our terminal again. And you may have to exit out of the Python interpreter and restart it for this to work properly. So now we can say again, we want to import my stuff like this. And we should still be able to basically call the apple function as we did before. And of course, it still returns the same value or prints IMApples here to the console. But now we can also access the variable tangerine. And of course, we need to make sure that we type mystuff.tangerine to actually access the tangerine variable inside of this mystuff module. And now we get back here the value that we defined before in our code file. So in a way that's similar to the dictionary that we have been using before, but the syntax is a little bit different. So if we get a value from our dictionary, then we used those brackets here, for example, mystuff, open bracket, and then the key to get the value associated with that dictionary. If we want to get a value from the module, then instead we would use the dot operation and then pass in this case the name of the function that we defined, which means that we also need to include the parentheses here at the end. And if instead we want to access a variable from within our module, then we would just type the name here. And of course, we don't have the parentheses since we only use those, for example, this case, for the function. So that means the effect is kind of similar, but the syntax is different when working with a dictionary as compared to a module. So that means that we have a very common pattern in Python. We take a key value pair style container, and then we get something out of it by the key's name. So we use the key to refer to the value associated with it. And in the case of the dictionary, of course, we are using the curly or the bracket notation here. And in the case of a module, instead we use the dot notation. So dot key to basically refer to that. So these are modules which we already used before. And now when we take a look at object-oriented programming, classes become very important, and classes are like modules in a way. So we can think about a module as a specialized dictionary that can store Python code that we can access with a dot operator. And Python also has another construct that serves a similar purpose called a class. So class is a way to take a grouping of functions and data and place them inside a container so that we can access them with a dot operator. So if we take another look at the mystuff module, we can actually change it. So let's just open it back up again here. And instead of directly writing the function and the variable in here, we can rewrite it basically to use a class instead. So we would type a class mystuff, pass in an object, and then we first of all are gonna write out the init function, which is called automatically when we create a new object from our class. And here now we type out again tangerine, which is a variable we used before, but now we have to type it a little bit differently. We're using self.tangerine, and self would always refer to the class, or to the object rather, itself that we are working with. We also define our apple method, or the function that we used before, and when we use that in association with a class or an object, then we would call it a method. And here again, we type out some text. And we need to make sure that as we define that, we pass in self, which is the object itself, and we also do that for init. So let's save this for now. And on first sight, that looks complicated compared to modules that we worked with, but we can kind of see a lot of similarities. For example, the Apple function here that we already used in our module is also shown here. What's most confusing is the init function here with the two underscores, init underscore underscore, and then the parentheses, and that we use self.tangerine rather than tangerine. And the reason why we use classes instead of modules is that we can use this class here and we can create objects out of that. So basically we can use our class as sort of a blueprint and then create as many objects out of that as we'd like. We can make some adjustments based on those objects. So for example, we can pass in different variables as we create those objects out of classes, and the class basically works as sort of a factory. We create many objects that we can work with. So in order to better understand that, let's understand what actually objects are. So objects, which are basically what we would create out of those classes, out of those blueprints. The objects would basically be the result that comes out of it. So if a class is like a mini module, then there has to be a concept similar to import, as we used before when we were working from our terminal, but for classes instead. And that concept is called instantiate. So we would basically take our class and instantiate a new object out of that class. So it basically just means to create a new object. So we instantiate or create a class by calling the class like it's a function, like this, for example. And let's switch over to our terminal here. Just gonna quit out of this. Or rather, let's just include this in our code file here. So if we define the class here, then afterwards what we can do, then we can see it all on one page. We can go ahead and we can define a new object, thing, and we assign myStuff to it. So myStuff is the name of the class, which creates a new object using myStuff and stores it in thing. And once we created this object here, thing, then we can start to call different methods on it, or for example reference any variables associated with it. So this thing object here now has been created out of this class, and we can now access any of those functions here that we assigned. So for example, we can go ahead and call Apple on it, like this. And then we can also go ahead, call print. And now we can call, again, we take our object here, thing, and call tangerine on it. So and if we now switch over to our terminal and we execute the code, then we get back, first of all, I am classy apples. So this is our function here that we are calling on the object. And then we print out the content of our variable here of tangerine. So this is the second line here. So to take a closer look at that, the first line, thing equals myStuff, is the instantiate operation, and is a lot like calling a function. But Python coordinates a sequence of events for us behind the scenes. And this is basically the steps that we are taking. So first of all, Python looks for myStuff and sees that it's a class that we defined. So if we take a look at it again, it sees that basically myStuff here is basically this class here. Then Python creates an empty object with all the functions that we have specified in the class using def. So that means basically those two functions here. Python then looks to see if we have a magic init function, which we do have indeed. This is the first function here. And if we have that, which is true for us in our case, then it calls that function to initialize our newly created empty object. So whatever is inside of init is then being executed. In the myStuff function init, we basically then get this extra variable self, which is that empty object Python created for us, and we can then set a variable on it just like we would with a module or dictionary or any other object basically. So init is basically called automatically, and then we can use self to basically set a value to our newly created object. So self.tangerine basically means that for a newly created object, we set the variable tangerine to the string here, and then later on we can refer to it as we do down here. In this case, self.tangerine is set to a song lyric, and then we initialize this object. And now Python can take this newly created object and assign it to the thing variable for us to work with. So this is basically the first line here. And this is slightly inaccurate, but this is just a foundation so that we understand what's going on in principle, and then of course we can build up on it in more detail. The truth is that classes and objects are at this point quite different from modules. And to be more specific here, classes are like blueprints or definitions for creating new mini modules. Instantiation is how we would make one of these mini modules and import it at the same time. So instantiate just means to create an object from the class, and the resulting mini module is called an object, and we can then assign it to a variable to work with. So let's take another look at some different examples. So we have three ways to get things from things, basically. The dictionary style, where we use the name of the dictionary, for example, myStuff, and then in those brackets we pass in the key. The module style, which we saw afterwards, where we used myStuff dot and then the name of a function, for example, or the name of the variable, where when we use a variable we wouldn't use those parentheses, but just the variable itself. And then finally the class style, where we start out by instantiating or creating a new object by typing in the name of the object and assigning it to the name of the class, followed by parentheses. And then after that it's quite similar to the module style in terms of syntax. So we would type out the name of the object we just created, followed by dot, followed by, for example, the function, or followed by the name of the variable that we want to work with. So we basically see some similarities between these three different key value container types. But let's now take a look at a little bit of a more extensive example here to get more familiar also with the vocabulary. So let's get started by writing this song class here. And to do that, let's open our terminal again. And for right now, I'm just going to call this exercise40.py to create a new Python file. And here we start out by defining a song class. And again, we're going to have an init function, which now takes two inputs, self and lyrics. And then inside of this init function, we now call self lyrics and assign that to lyrics. So basically that means that whatever we pass in when we create the song, this will be taken in as lyrics, and we store that back in a variable that's called just the same, but we need to use self in order to basically make sure that the value that we assign is actually assigned to the object. Next, we are defining a function, sing me a song, which uses a for loop. And for each line within a lyrics, which we passed in when we created the object, we're gonna print out each individual line. Now, outside of our class that we created, we can now go ahead and create a new variable called Happy Birthday, and we pass in the lyrics to Happy Birthday. And also some additional other text, and let's just type it like this. Okay, and then we have another object that we create, and again we take song here and we pass in a different text, different lyrics. And now finally, once we have done that, we can use our objects here, for example, the Happy Birthday object, and then call Sing Me a Song, which is of course the function we defined here. And we can do the same with our other objects that we defined. Let's just correct the typo here. And again, we call Sing Me a Song. Let's save this and let's hop over to our terminal again and execute the code. And now we basically see that we type out or we print out each line here. So Happy Birthday to you, and so on and so forth for Happy B-Day, the first object, and then the second object here, we have those two lines and they're also getting printed out. And that's basically how we can approach that using a function, or rather using a class, defining that as a class. And now we have the code in here and we can use it in different ways. Here, for example, we just created two different objects with different texts that we passed to it, and then we can simply print that out. So we just need to define that code up here in the class once, and then we can reuse it for different songs. So if you wanted to create an additional song, which is actually the first study drill section here, we could, for example, define another object. And then in a similar way, we would again pass in the song lyrics like this. And then, of course, after that, we still want to take our object here that we created and then call Sing Me a Song on it, like this. And now if we go ahead and execute that again, then we see the second, or our line actually is also printed out. So that's how we can very easily create additional objects here using that notation, and then of course calling those functions on those objects as well. We can also, in a second study drill here, put the lyrics in a separate variable and then pass that variable to the class to use that instead. So if you want to do that, we can, for example, say we have here, let's say Happy B-Day lyrics, and then we take all of that here and we pass it in here, and now we can have separated that out a little bit more. We can type it in like this, and of course we could do the same for the other songs here. Let's see if that still works. So in this case, it just prints the same information out as before. That's just one additional step that we can take so that we can separate it out a little bit more. So see if we can actually hack this and make our class do more things. So just let's take a look if we can adjust that. So one thing we could do, for instance, is that we add in additional functions. So we could, for example, say here it should do something else. And for now we can say do something else. So we type that out. And now, since we already instantiated those objects here, we could just take any of those, for example, another song. And now we should be able to just call something else on it. And it should then print out do something else. Let's see if that works. And indeed it does print this out. So we can extend it, we can add additional functions to it, we could add additional properties or variables to it to work with it. That would all be possible. And finally, the last study tool question here: search online for object-oriented programming and try to overflow your brain with what you read. Don't worry if it makes absolutely no sense to you. Half of that stuff makes no sense to the author either. So if we take a look online, there's a bunch of different information about object-oriented programming, of course, but this is, for example, one article that can be quite helpful. So object-oriented programming explained in depth. So object-oriented programming, OOP, is a fundamental programming paradigm used by nearly every developer at some point in their career. It's the most popular programming paradigm, and yeah, it's a standard way of programming basically. So if you take a look at that, again, we learn about classes and objects that we are working with. We can use it to structure a software program into simple reusable pieces of code blueprints, which are the classes, which can then be used to create individual instances of objects. And there are a lot of different object-oriented programming languages, such as JavaScript, C++, Java, or Python, of course, which we are working with. And there's a lot of additional information, including a detailed description of classes, of attributes, and then of methods, which are basically the functions inside of classes that we are working with. And we can use that to work with classes, to define classes with different attributes and different methods, and then create objects out of that and assign certain attributes to those objects that we create. And therefore we can basically use our class as sort of a blueprint and then create individual instances of that class, which can have different attributes, for example, that we are working with. And I'll also link that article in the description below, so you can take a closer look at that. And then finally, common student questions. Why do we need self when we make the init function or other functions for our class? So if you take a look at the code again, we see that we always use self here and here as well. Why is that necessary? So if we don't use self, then the code, like for example, cheese equals Frank, or in our case here, lyrics equals lyrics, like this, is ambiguous. The code isn't clear about whether you mean the instances cheese attribute, for example, or a local variable named cheese. So for example, in this case, it's unclear if we mean, here in lyrics, if we mean the variable associated with our class, with our object that we're creating, or a local variable. If instead we're using self dot, name is a variable, then it's very clear that we want to attribute it to the current object that we're working with. So therefore, if we should always use self dot and then the variable name if we are working with that, just to make very clear that we actually want to assign it to the current object that we are working with. So that's it for exercise 40 and object-oriented programming, and see you guys in the next video with the next exercise.